to another episode of Homework with Ms. Thomas. I am Ms. Thomas, and today we are exploring Lesson 3 of Module 3. The objective is to demonstrate an understanding of area and perimeter formulas by solving multi-step real-world problems. Let's jump right into it. Okay, for these problems, we are going to use pictures, numbers, or words to show our work and solve the problems. For number 1, Katie cut a rectangular piece of wrapping paper that was 2 times as long and 3 times as wide as the box that she was wrapping. The box was 5 inches long and 4 inches wide. What is the perimeter of the wrapping paper that Katie cut? So they tell us that there's this rectangular piece that's 2 times as long and 3 times as wide as this box. So we have 2 different things that we need to model here. So I'm going to start with the box because we know what the box is. Okay, they tell us that it's 5 inches long. So I'm going to put 5 inches for the length. And then they also tell us that it is 4 inches wide. So for the width, I'm putting 4. Now, this wrapping paper is 2 times as long as it is wide and 3 times, it's 2 times as long as the box and 3 times as wide as the box. So for the length, I'm going to do this 5 2 times. And so here's 1 5, right? This is one of the 5s, and then this is the second 5, right? I can even label this 5 and 5, right? We're doing the 5 2 times, making a length of 10 inches. Now for the width, they tell us that the width is 3 times the width of the box. So I'm going to do 3. What am I doing 3 times? The 4 inches. So what is the total width? It would be 4 3 times, which is 12. So we have a length of 10 inches. This is for the box. And a width of 12 inches for the box.
My mistake, everyone. This is the perimeter of the wrapping paper, not the box. So we're finding the perimeter of the wrapping paper.
So that would be 10 plus 12 2 times. 10 plus 12 is 22. Right? 10, 12, 22 times 2 gives us a perimeter of 44. Right? 22 and 22, that's what 22 times 2 is, right? Makes 44. And it's so important that you include the inches, the units. Remember, we're not doing area, so it wouldn't be square units. It would just be what the units is, and in this case, it is inches. The perimeter is 44 inches. Again, the perimeter is 44 inches. Let's go on to number 2. Alexis has a rectangular piece of red paper that is 4 centimeters wide. Its length is twice its width. She glues a rectangular piece of blue paper on top of the red piece measuring 3 centimeters by 7 centimeters. How many square centimeters of red paper will be visible on top? Okay, so for this problem, we have a rectangle that is red. So I'm going to use my red color. Feel free to use a red marker or pen or crayon so that you can see this is the red paper. So we have, it's 4 centimeters wide. They tell us that the length is twice the width. So for the length, I'm going to do the width twice. Twice would be 2 times. Right? So I'm doing 4 centimeters and 4 centimeters. That makes 8 centimeters. They tell us that, and I'm going to just erase this line so that we can make this blue on top. They tell us that she glues a blue paper at the top of the red paper and that it measures 3 centimeters and 7 centimeters. So I'm going to make this, mark here. It's not 4, it's 3. So I'm going to, how can I show this? I'll just put 3 on top there. And then it goes, not the full 8. We'll stop it here. And on top here, I'll write that this is 7 centimeters. So this is the blue. Blue here, that's on top of the red. They want to know the square centimeters of the red paper that's still visible. So they're asking you about this part of the construction paper. They want to know about the red part. So actually we can erase these lines and just focus on the red part. Okay, so first, I need to figure out what the red part is. What's the red part total? And then, once I know what the total is, then I would subtract the part that I do know, and then I'll know the part that I don't know. So they tell us that, we know that area is length times width. So in order to get the area of the red, and let's put it in red. In order to get the area of the red, we know that it was 4 times 8, right? Remember we did that 4 doubled, and that's how we got 8. So then that makes the area of the red 32 square centimeters. Remember, you're dealing with area, you say square. Now, for the blue is 3 for the width and 7 for the length. So that would be 3 times 7. That gives us 21 square centimeters. So if I want to know the area, and let's make this a little a. If I want to know the area of the part that I don't know, then I would subtract the red area minus the blue area. And then that would give me X, right? This is the part that I don't know, the part that's still visible. So let's do it. We're going to subtract 32 minus 21. I don't need to regroup. 2 minus 1 is 1. 3 minus 2 is 1. So it's 11 square centimeters still visible? Let's write that. How many square centimeters of red paper will be visible? There will be 11 square centimeters visible on top. Okay. Brand's rectangular kitchen has an area of 81 square feet. The kitchen is 9 times as many square feet as Brand's pantry. If the pantry is 3 feet wide, what is the length of the pantry? Okay, so we have a kitchen and we have a pantry. So I'm just going to label this here so we know what we're talking about. We have the kitchen, we have the pantry. The kitchen has a area of 81 square feet. They tell us that the kitchen, I'll do K for kitchen, is, and equal for is, 9 times as many square feet as the pantry. Let's do the pantry for a P for pantry. So here's the formula that I'm going to kind of base that on. If I do the pantry 9 times and I get the kitchen, that means the pantry is smaller. So I'm going to do this rectangle smaller than the kitchen because it's 9 of these in the kitchen is essentially what they're saying. I can fit 9 pantries in this kitchen. So I probably could make it even smaller so that it looks like it's 9 of them. But let's leave it here. They also tell us that the pantry is 3 feet wide. So I'm just going to put 3 feet here. Okay, so we know that the pantry is 3 feet wide. They don't tell us what the area is. We need to find what the length is. Now, let's take this formula that we do know about the kitchen. We know the kitchen's area, and I have this K for the kitchen area, is 81. We also know that the pantry is 9 times that. So I can figure out the area of the pantry by doing the inverse of multiplication. I'm going to divide by 9, right? Because if I divide 9 times P divided by 9, then that gets rid of that 9 times, and it just leaves the P completely by itself. But what I do to one side of the equal sign, I have to do to the other side. So on the other side, I'm going to also divide that by 9. That makes the area of the pantry 81 divided by 9, which is 9. And I can get 81 divided by 9 by counting by 9 to 81. So now I know that the pantry is 9 square feet. Area equals length times width. We have to figure out the length. Length equals area divided by width. Same thing we just did with the other problem. We did the inverse. So I can figure out the length if I divide the area, which is 9, by the width, which is 3. 9 divided by 3 is 3. Meaning that the length of the pantry is 3 feet. Let's write that. The length of the pantry is 3 feet. Let's move on to the final problem, number 4. The length of Marshall's rectangular poster is 2 times its width. If the perimeter is 24 inches, what is the area of the poster? Okay, so we have a rectangle. We know that the perimeter is 24 inches. We also know that the poster is 2 times its width. So the width is W. We don't know what it is. But the length is 2 W's. Right? We're going to do W 2 times because it says 2 times its width. So the width is W, the length is 2W. We also know that perimeter equals length plus width plus length plus width. Or we could do length plus width times 2. Or we could do 2 lengths plus 2 widths. I'm going to do it like this so that we can clearly see what we're adding. So we're going to add the W plus the 2W plus another W, because this side is also W, plus another 2W, because this side is W. So we have 1W, 2 W's, so that's 3 W's, plus another is 4 W's, plus another is 6 W's. Right? We have 2, 4, 5, 6. So P equals 6 W's. They tell us that the P is 24. So instead of writing P, I'm going to write 24. And that equals 6 W's. So I am really multiplying W 6 times. Right? This is the same thing as this. 6W is the same as 6 times W. I'm doing W 6 times. I can undo multiplication by, you guessed it, dividing. So I'm going to divide 24 divided by 6, and that'll give me W. 24 divided by 6 equals, I'm just going to put W first this time, it equals 4. And I got that by counting by 6 to 24. Right? 6, 12, 18, 24. 4 6s. And I could even check that by plugging this back in, right? If I do 6 times 4, I indeed get 24. Okay, so now we know this side. We said W equals 4. We know this side too. We're going to do 2 4s, right? That equals 8. This is also 4. This is 8. They want to know the area of the poster. Let's just scrunch this in so you can see all of this work. Area equals length times width. The length is 8, and the width is 4. So in order to get the area, I'm going to do 8 times 4. 8 times 4 equals 32. And I'm going to make sure that I put that square because they're asking for area. Square units. Oh, no, inches. Look here in the problem. They tell you 24 inches. So I know that I'm using inches. Okay, let's write that statement for the answer. I'll just write it up here. The area is 32 square inches. The area is 32 square inches. All right, that concludes the homework for lesson 3 in module 3. Hopefully this helped you do your homework. Till the next time, keep learning, and I'll see you in the next episode. Talk to you soon. Bye.